Hello and welcome back to California Geology. I am going to continue on with the San Andreas system and in particular talking about seismic gap here. So seismic gap is a way of saying that there's a part of the fault line that we know is active. So the San Andreas fault is active. It's a major plate boundary, but yet there are regions along the fault that have not ruptured in historic time. So that fault, or at least that segment of the fault, is said to be locked in, and it's accumulating strain energy. And it has been accumulating strain energy since before the 1850s, because that's really when the state of California began to become populated after the gold rush. And then we started keeping good records about earthquake. And in fact, the earthquakes, really by 1875, we were starting to keep really good records of the different earthquakes. So, but anyhow, these areas have potential for future earthquakes, right? And as an example to that, the Loma Prieta earthquake of 1989 was actually predicted. And this is it's sort of a cross-sectional hypocenter or focal depth chart going from San Francisco north, south toward through the Santa Cruz Mountains here. San Juan Bautista would be right here. Parkfield is over here. And note that on this diagram, before 1989, so this top one is pre-1989. So before 1989, this pre-1989 one, you see that there's a gap here. So they call this the Loma Prieta Gap, right? Loma Prieta Gap. And then the 89 earthquake comes along, and this is the chart for the 89 earthquake. So if you were to superimpose this strip along this one, it would fill in that gap. Other things to notice is that there is a gap over here. In fact, this was the Paso Robles, the Robles gap, right? So we know that in, was it 2006? But anyhow, in the 2000s or so, 2006 or so, there was an earthquake there, about a magnitude 5.4, 5.6, that now has partially filled in this gap there, right? So that was another area that was predicted to have an earthquake, another seismic gap. And then note that there are others. South San Francisco, Portola Valley, Los Altos Hills is a place that has not ruptured in historic time, even though we know that the San Andreas transform is an active boundary. So these areas are overdue. They're due for an earthquake. Now, so seismic gap theory states that successive earthquakes along a fault will eventually outline gaps where succeeding earthquakes are likely to occur. And that's what we saw on that diagram back over here. And there is a current gap in South San Francisco Peninsula. Remember, Portola Valley, South San Francisco. So on the San Andreas fault proper, that would be the next place to expect an earthquake. Although, as we'll see in a little while here, there's a higher probability of an earthquake on the Hayward fault after this March 2015 new earthquake study. So the Calaveras fault branches off of the San Andreas fault south of San Juan Bautista. It runs through the town of Hollister, and it's world famous for the creeping segment, right? And I showed you the picture of the sidewalks and walls of homes being offset. Remember in 2007, we had the Alum Rock quake, and that one has had some pretty good Rayleigh wave motion. It felt like you were on a boat, right? There was some damage over there in East San Jose, and that was a magnitude 5.4 quake. So there you go. Even though it's a creeping fault, it still has a potential for larger magnitude earthquakes. Now, if we look at the Hayward fault branches off of the Calaveras fault east of San Jose, runs through the East Bay cities of Fremont, Hayward, Oakland, Berkeley, and then runs through many housing projects, freeway overpasses, schools, hospitals, and it goes right through the middle of UC Berkeley Stadium. The Hayward fault is considered to be the most dangerous fault in the Bay Area because it passes through the urban core of the East Bay. The San Andreas fault is not so densely populated. It runs south of Daly City, offshore of the Point Reyes Peninsula. In fact, San Francisco is about as close to the Hayward fault as it is to the San Andreas fault. And supposedly the ferry building there in San Francisco is about halfway between the San Andreas and the Hayward Fault. Now, the Hayward Fault is creeping, and before 1989, it was moving at a rate of about half a centimeter per year, 5 millimeters a year. But then after the 89 earthquake, it slowed down to about 0.1 centimeter per year, or 1 millimeter per year, right? So the Hayward Fault is commonly divided into this northern segment and the southern segment. And so in 1868, there was a large magnitude earthquake, about a magnitude 7. Some say 6.8, but it was about 6.8 to 7 magnitude earthquake that broke the southern segment for about 30 miles and at an offset of about 3 feet, so a little over about a meter of offset. And recent studies looking at recurrence intervals on the Hayward Fault, because it is a very dangerous fault, we find that that the northern segment of the Hayward Fault ruptures about every 140 years, with a magnitude 7 earthquake. And it's been, well, I guess 2008 was 140 years. So it's been over 140 years since it's ruptured. So we're overdue for a large magnitude earthquake on that Hayward Fault. And chances are about 31%, or 1 in 3, of a magnitude 7 quake on the northern section of the Hayward Fault, or this Rogers Creek Fault, in the next 30 years. In fact, here's a map showing some of the latest studies, and it kind of looks at the whole San Francisco Bay region, and it does a probability between 2007 and 2036. So now we're in 2015, so we're getting close to there, and it has a probability of 63%. I think that number now is around 67%. 67% probability that we're going to have an earthquake of magnitude 6.7 or greater on any of these faults in the Bay Area. And if we look at the San Andreas Fault proper here, San Andreas Fault, you see there's a 21% chance that will be the one to have the quake. The San Gregorio Fault down here off of Half Moon Bay, there's a 6% chance on that one. The Calaveras Fault over here has a 7% chance. And then the one that's really kind of highlights is the northern section of the Hayward Fault. It's going to have the highest potential, 31%. So this fault is overdue, and it has the highest probability for having this quake, magnitude 6.7 or larger, in the Bay Area. So that's why it is considered the most dangerous fault in the Bay Area. Now, if we look at the fault off of Santa Cruz there and over towards Half Moon Bay, the San Gregorio Fault, it used to be the Monterey Bay Fault Zone. But this fault is mostly offshore, passes through Monterey Bay, and touches land at Point Año Nuevo. It goes back offshore at Point Año Nuevo, then comes back onshore at Half Moon Bay there, right? And it's just to note some important earthquakes there. In 1926, there were 2 magnitude 6 earthquakes in the same day on that fault. And so there is speculation that this one can have also a magnitude 6 earthquake or larger. And note that it's a 6% chance for this San Gregorio Fault here, right? So it does have potential for a large earthquake as well.